So, hi everyone. Today we'll be doing remainder bounding. Just ignore that. It's like remainder bounding, not construction geo. So basically, it's like on Euclidean algorithm. So I assume that you people would have studied the Euclidean algorithm to find greatest common divisor in like school classes. What you basically do is like suppose you have to find, let's say GCD of uh, 18 and 34. So you do something like this. 16, 18, 216. So the GCD is 2, which is basically the same thing as writing this as GCD of 18, 34 minus 1 time 18, which is equals to GCD of 18, 16, which is equals to GCD of 18 minus 16, which is 2, 16, and which is 2. So this thing can be written like this. So what that means is basically GCD of A, B is same as GCD of x times A minus y times B, B, where GCD of x, B should be kept 1. So does everyone get that? Why should this be true? If not, then I can tell you, like, take a minute or two and think, why is this true? Also, I think and x is not equals to 0. Yeah, now this should be fine. So is this thing clear to everyone, people? Okay, this looks stable.
Yeah.
Okay, nice. So in today's session, the main idea is to like deal with the problems revolving around divisibility. So like you're given some problem which has A divides B, and you have to do some stuff. So what is the common idea? Like we'll first discuss the idea and then we'll see the problems. So when you're given A divides B, this means that uh, modulus of A is less than modulus of B, like at most modulus of B, or B equals to 0. Like this should be true, right? Suppose A is 7 and B is 3. So like 7 will never be able to divide 3, right? Because 7 is greater than 3. So like for a number to divide another number, it should be less than that. Or B should be 0 because everything divides 0. So we have to basically like in divisibility problems, this is the main thing to use. I mean, not always, but most of the times you have to bound it like that. But if you see that this is a very big, weak bound, right? So, okay, saying weak is a bad thing. But okay, what I want to say is a better thing to notice is if A divides B, then A also divides B minus A. And you can keep on doing this, which means that A will divide B minus K times A. So the idea is you keep on doing this until this term is greater than 0, and you would possibly want to make this thing less than A. Or a better way to say this is a modulus of B minus Ka less than A. You would possibly want to do this because this means that this is a contradiction and like you basically narrow down the conditions. Does that make sense? Like, okay, without a problem, it sounds a bit vague. Okay, so I think we can do a problem first and then see what I meant by this thing. Question. Determine all pairs of positive integers such that xy square plus y plus 7 divides x square y plus x plus y. Take 2-3 minutes to try this problem, and if you have any idea, like just speak up. To people who just joined, we have just begun and we are like discussing the first problem. This is the problem, and you can take 2-3 minutes to try it, and like if you have any idea, you can tell. Okay. Does anyone have any ideas? Or like even saying that what you are trying to do will be fine. Yeah, go on.
I think that we might start trying to do the formula of b minus a and then a divided by that.
Sorry, can you please repeat? Like the voice just cut in between.
Sorry?
Can you please repeat? The voice just cut in between.
Yeah, of course. So maybe we can like first do the b minus a
Okay,
and
so
then a divided by that number.
okay, so you're basically saying that this thing will divide this.
Yeah.
Okay. So you can cancel out the y, and then you have xy, x minus y plus x minus 7 remaining on the right hand side. So the issue here is like this is a good step to start with, but if you see that you have a 3-degree term here, right, and still a
Mm-hmm.
3-degree term here, so you can't really say about the size. So if you say that okay, if x this divisibility implies that this thing must be less than this thing, right? But how do you force a size contradiction here? Because like both the things are 3-degree, and you do not have much condition on x and y. So like this doesn't help much, right?
Yeah.
But this is a good point to start with. Instead, what we do is we want to okay. So from here we see that we have to cancel out this 3-degree term. Then only we can like think about size better, right?
Then can you multiply the right hand side by y, left hand side by x and subtract?
Yeah. So what we do is we'll multiply this thing by y. Like even if you multiply this by y, this thing will still divide this thing, right? So xy square plus y plus 7 divides x square y square plus xy plus y squared. And now we can subtract x times this thing. So we will get that xy square plus y plus 7 will divide y square minus 7x. Now it is a better thing because here you have a 3-degree term and here you have a 2-degree term at max. So considering the less than equal to thing will help a lot more. Also, the motivation to multiply it by y was you would want that xy square will divide whatever thing you multiply with times x square y. And the minimum thing you need to multiply is y. So multiply y and check if that really works. So is this clear why we did this? Yes or no? I think.
Yeah.
it's
Okay, nice. From now, like, so here you have 3 cases. Like basically, xy square plus y plus 7. This is always positive. This should be less than modulus of y square minus 7x or y square minus 7x equals to 0. This thing will give you 2 cases. So that is how you get 3 cases. If this is positive or negative, and if this thing is 0. So try to work out these cases. If you get anything, like take 2-3 minutes more. Yeah, this is the first problem. We're basically like trying to discuss a problem and then we'll see some ideas and we'll do more problems. It will be better to discuss the ideas after this problem, the general idea in these kind of problems. Did anyone get anything for any of the 3 cases? Okay, so let's first begin with the case when y square minus 7x is greater than 0. This means xy square plus y plus 7 must be less than equals to y square minus 7x, which means y square times x minus 1 plus y plus 7x plus 7 must be less than equals to 0. Now we have that x and y are positive integers, right? So x minus y will be at least 0. Like x is at least 1, which implies x minus y is at least 0. And so is y square times this thing at least 0. And we know that y plus 7x plus 7 is obviously greater than 0. Like you can strengthen the bond, but you don't really need that. Which means that this whole summation should be greater than 0. But this says that it should be at max 0, which is a contradiction, right? Which means that this is not possible. Now, in the second case, let's take y square minus 7x to be 0. This means y square equals to 7x. Notice that 7 should divide y, which means we can write y to be 7k. This implies 49k square must be equal to 7x, which implies x should be 7k square. So now if we try to put these values like y is 7k and x is 7k square in the original expression, we have left hand side, which is xy square plus y plus 7. You can do calculation on your own, but I'll just write what it becomes. 343 k to the power 4 plus 7k plus 7. And right hand side is x square y plus x plus y. And this thing becomes 343 k to the power 5 plus 7k square plus 7k. And this thing obviously divides this for all values of k, right? Which means that all x comma y equals, sorry, man, it is hard. Equals to 7k square comma 7k is a valid solution. The last case we have, you should try this on your own, is when y square minus 7x is less than 0. Then you should have that okay, since y square minus 7x is less than 0, this thing should be 7x minus y square. And try to do this case on your own, maybe as a homework. It's not that direct. I mean, it's just one line more. So yeah, try to do this on your own. Okay, so is the problem overall clear? I'll just write the solutions which you get from here, by the way. 11, 1 and 49, 1. So you have three solutions. One is 7k square, 7k, and the other two are these two. Okay, so is the problem clear to everyone? Like, how do you motivate this step? This is the main part of the problem. Okay, one person said yes. It will be nice if more people can say yes or no. Or
Yeah, it's
okay, nice. 2 people. Okay, so if you have doubt at any step, you can ask freely. Okay, so since we have done a problem, let's just see what I was saying earlier. So whenever you have that A divides B, then we can write this as A divides B minus KA for some appropriate value of K, which helps taking the bounds easier, like such that this gives you a nice contradiction. But there is more which we can do, just as we did in this above problem. Since A divides B, this means A also divides T times B. And then you can do A divides T times B minus K times A. Like, it's good to ensure that if you can, that GCD of T comma A is 1, so that you do not lose out on information. Like, let's say A is 7, and you're given that B is some, let's say f of x, and you're given 7 divides f of x. And you want to write this as 7 divides some k times f of x. But if you take k as 7, like 7 divides 7 times f of x, this is just obviously true, right? You do not get much, like, in fact, you lose the stronger condition which you had already. So it's good to ensure that GCD of t comma a is 1. But if you cannot in some problems, it's fine. Like, don't be too rigid on that. Like in this problem, the main idea was to multiply this thing by y and then subtract x times this thing. So as to remove the 3-degree thing which you already have. So this is one of the main ideas. Another idea, I am not sure if I have a problem on that idea for today, but I'll still tell the idea. It's like a good idea in these kind of problems. If you have A divides B, if you have A divides B, it's good to consider prime factorization of B. Not prime factorization, like any kind of factorization. So if you write A as B1 times B2, and if somehow see that GCD of A comma B2 is 1, then this will mean that A divides B1. So what is the benefit of this thing? From here you had that A should be less than equal to B. Also, I'm assuming A comma B is greater than 0, just for the sake of simplicity. But from here, you get that A is less than equals to B1. And notice that B1 is less than equals to B, less than B. So this is a stronger condition than this thing. So you basically get more information in some sense than what you had earlier. So that is why considering the factorization of the thing here is a nice idea. So are these two things clear? Like what I'm trying to convey. Okay, nice. Just a second, let me find the nicer problem. Or did someone say something? Sorry, the voice wasn't clear.
No, no.
Okay. Question. Oh, by the way, the first one we did was IMO 1984 P4. So basically, like with the standard ideas, you can do an IMO problem, which is good. Which means that this idea is useful, and I'm not teaching nonsense. If you were curious. Let me just start the problem first, and then I'll explain. Okay, so the problem is saying that we have to find all n greater than equals to 1, like all positive integers, such that there exists a comma b, such that a square plus b plus 3 is not divisible by cube of any prime, and n is of the form ab plus 3b plus 8 divided by a square plus b plus 3. Basically, this thing divides this thing, and n is the quotient of these two. Okay, for now, is the problem clear, by the way, to everyone?
Yeah.
Okay. For now, just forget this condition for now, and try to deal with this divisibility condition first. Take 2-3 minutes to try. Has anyone seen the problem before, by the way? I'm curious.
I think I've seen some problem with like not divisible by cube of any prime, but I've not seen this problem. I think.
I think
I
this
see.
is from HMMT.
That is not the correct source, by the way.
I'm pretty sure HMMT has only one answer.
I mean, it's possible that this problem also has only one answer. Okay, anyway, try the problem.
Shortlist 2021 N1.
Did you like go on? Oh, wait. Okay. Did you like go on Google and search it?
Like I
yeah,
can't Google it.
Fine.
I think this was I think
Kanav also discussed this.
Oh, fine.
yeah,
Yeah.
in the divisibility lecture.
Okay, you have seen the problem. Then I won't do those. Okay. Let me find another problem. Well, let me know if you have seen this problem. Have you people seen this problem?
I have not.
Okay, nice. Yeah, try this problem then.
Well, I mean, first thing we see is just
Yeah, go on. They cannot hear you.
yeah. So A divides A to the 2017 plus B, which implies A divides B.
Sorry, can you repeat? I was not able to hear you.
I mean, A divides A to the 2017 plus B, so A must divide B.
Yeah, that is a good point to start. So we have that AB divides this thing, which means that A must also divide this thing alone, obviously, which means A divides B. Okay, so what do we do now? Okay, like we have A divides B. So we set B as A times B1. So try to do what you get now.
Then I guess A divides B1 again.
Yes. So what we do is, now we put b equals to ab1 in this original equation. Then ab1 divides 8 2017 plus 8 times 17. So we can cancel out 1a and get something like
Yeah,
this is it.
2016, right?
Yeah. b1. And then you similarly get that 8 also divides b1, which means that b1 plus- yeah, b1 equals to a times b2. And you'll basically keep on doing this. Eventually you'll get AB 2016 divides A plus B 2016. What do you do now?
Yeah. Now again A must divide B to the B 2016. So and now we end basically. So A divides A to the sorry.
Okay, what now?
I mean now A is not left, right? A is
Yeah.
just gone.
So what do we do now? Wait, you have a here, right?
How do we have the
Like similarly, like you had a here also, right? So okay, you write B 2016 as A times B 2017. So this here you'll have like a square. Oh, you do not have a.
yeah exactly.
Oh,
So B
fine.
2017 is the last B.
Oops, sorry for that. Okay, yeah, fair enough. Okay, what do we do now?
Now B 2017 must be 1.
Why?
Since B 2017 divides 1 plus B 2017. So it
Wait,
has to
let
be 1.
me introduce some error. Okay, yeah, fine. Sorry, that's fine. Yeah, so B 2017 divides 1 plus B 2017. This means that B 2017 must divide 1, which means it can be either 1 or minus 1. But since we're dealing with constant integers, we only have 1. So B 2017 must be 1, which implies A must divide 2. So A can be 1 or 2, right?
Yeah. So we
So
can just backtrack now.
yeah, if you notice that B is basically A to the power 2017 times B to the B 2017, right? Like B is A times B1, which is A times A B2, which is A square B2, and you keep on doing this. So this is B eventually, right? So now A equals to 1 implies B equals to 1, and A equals to 2 implies B equals to 2 to the power 2017. So the two solutions are 1 comma 1 and 2 comma 2 to the power 2017. So is the problem clear?
Won't it be 2 to the yeah right.
Yeah, nice. Okay, so is this clear?
Yeah.
Nice. Okay, I have two problems next. One is an APMO problem and another is an ISL problem, which is an FE. Which one do you want to do? Like people can just vote. If you want me to write the problems, I'll write them. One is n square plus 1 divided by find all n such that this is an integer. This is the APMO problem. And the next is find all functions f from positive integers to positive integers such that f of m plus f of n minus mn divides m f of n plus n f of n. This is an n6. Okay, which one do you want to do? As alpha says APMO. Anyone else?
Yeah, let's just do the APM.
Okay. Uh, find all n says that this. Take 2-3 minutes to try on your own, and like any potential idea you can take. N can be a perfect square and cannot be a perfect square as well. Like n is just an integer, positive integer. Does anyone have any ideas? Or like, should I give a hint or you need more time? Anything is fine. One thing I'll say is like everyone would have noticed that this greatest integer function of root n is like a very annoying thing to deal with, right? So for the first one, n is okay. Yeah, go on. Also, it will be better if you can unmute, and if you cannot, it's fine. You start. Oh, sure, no worries. Yeah, go on with the idea. Okay, so let's say that q square is less than equals to n is less than q plus 1 squared. So we can write n as q square plus m. Okay, the solution I have uses a bit different notation, but like it's the same idea. Oh, you have done this one. I'll give you another problem. Do that. Do not comment on this one. Do this problem, Rahul. Just note it down. Find all functions from positive integers to positive integers such that f of n plus f of n. Okay, let me find another problem. I've done this one. If AB are positive integers such that a to the power n plus n divides b to the power n plus n for all positive integers n. Prove that a equals to b. Nice. Do this then. Yeah. Yes, as well. So instead of q, I'll just use m. So m square less than equals to n less than m plus 1 squared. So we can let that n is equals to m square plus k, where k is less than equals to 2m and is greater than equals to 0. So now root n must be equals to, this thing should be m. So this squared should be m squared. So now you have that m square plus k squared plus 1 m square plus 2 divides this thing, right? So using what Azorfer said, we have reduced the question to this divisibility condition. Now, how do we solve this? Similar to the previous question. Not really, no. I mean, sure, it's written in a divisibility form now. Yes, easier to deal with, of course. But you know, this problem has a very nice idea, which is why I'm doing. Like, it's not that standard. Yeah, this is the trickier part, as Rahul said. Okay, take 2-3 minutes and make some progress. And yeah, if you're stuck, I'll give a hand. Oh, also, Rahul, if you solve the problem I gave, type the solution in like private chat, not publicly. That will be better. Okay, does anyone have any ideas?
We can write m square plus k as k minus 2 mod m squared plus 2.
Yeah, m square plus k is congruent to, that is actually smart. When I did this problem, I expanded the square and did the things manually, which is terrible. So this means that m square plus 2 divides k minus 2 square plus 1.
Yeah, and now k is at most 2m because that's how we
K
have
is
element k.
at most 2m. We wrote this thing here. Here. Yes.
I see.
Yeah.
And now like the ratio of k minus 2 whole squared plus 1 divided by m squared plus 2.
Mhm.
Is going to be at most like 4,
You get 4.
strictly less than 4.
Yeah. Okay. A better way to write this is like to motivate this thing. He saw it directly, but you can do this. So you have that this thing divides this, right? So it's sometimes good to remember, not remember, to write m square plus 2 times, let's say some t divides, equals to k minus 2 square plus 1. And now you try to find things about t. This is another idea in divisibility. So here, if you notice that k is less than equals to 2m, which means that this thing must be less than equals to 2m minus 2 square plus 1, which is less than equals to 4m square minus 8m plus 5. So now, if t is, let's say, greater than equals to 5, then you'll have a 5m square thing here, and this thing is less than 4m square. So this thing will be greater than this thing, which is not good. Similarly, if you can check for t equals to 4, this thing will be larger than this thing. This means that t should be at max 3, which reduces a lot of work, right? Now you only have to check for t equals to 1, 2, and 3. Is this step clear? Nice. So now we check these things. So let's say we check for 3 first, t equals to 3. You should have 3m square plus 6 equals to k minus 2 square plus 1. And you can say it's 5. Okay, what do we do for this case? Just say it, anyone.
A mod 3 contradiction.
Yeah. If you take mod 3, this will imply that k minus 2 square should be 2 mod 3. But squares are 0 or 1 mod 3. So this is a contradiction. For t equals to 1, you have m square plus 2 equals to k minus 2 square plus 1, which means 1 is equals to k plus m minus 2, k minus m minus 2. Which means that both of these should be equals to 1. K plus m equals to 3. This is also equals to 3, which means that k should be 3 and m is 0, which is a contradiction. And similarly, you can check for the minus 1 case also, you'll get a contradiction. Which means that t can only be 2. For 2, you will get 2 m square plus 3 equals to k minus 2 square. What do you do now?
Mod 4 gives k minus 2 and m are both odd. Like
If it take
k
mod
minus 2 is odd.
ice k minus 2 odd, mod 1, right? Or mod 2.
Yes. And then
Okay.
mod 4, you have m is also odd.
Okay, then
Mod 8. So that's just contradiction.
we do need mod 8.
Like mod 8, odd squared is 1 mod 8. So you get 5 is 1 mod 8, which is not possible.
Odd square is 1 mod 8. Yeah, so 3 is 7 mod 8, right? We did 5 plus 1 come.
Like original wala de.
Oh, fine. Yeah. And then mod 8 finishes. Wait, I think I had a different finish. I think it was like if you take mod 3, then k minus 2 square should be congruent to 2m square mod 3.
That's easier.
Yeah, but now k minus 2 and m both are 0 mod 3. And then mod 9, right? This also works, no?
Yeah.
Okay, so did everyone understand? So basically there are no solutions. It's like no such n exists. Is this clear? Okay, nice. We'll do this problem. A comma b are positive integers such that a to the power n plus n divides b to the power n plus n for all n belonging to positive integers. Prove that a equals to b. What was I saying? Yeah, this one is like not that related to divisibility ideas we have done, but it's still like a nice problem on divisibility, so we'll do it. Okay, any ideas? Okay, so it's slightly hard to think of ideas directly. So how do we use this condition? Basically, if something, let's say a prime p, divides a to the power n plus n, then the prime p also divides b to the power n plus n, right? So now you have to prove a equals to b. No, this is a common idea which you will see many times occurring. That to prove this, you basically prove that a is congruent to b mod p for some large prime p. Now, if p is very large, let's say it's greater than both a and b, then a congruent to b occurs only when a equals to b, right? So let's say we have some large prime p which divides a to the power n plus n, which means a to the power n plus n is congruent to 0 mod p. Now see, this thing is true for all n, right? Can you find an n such that this is true for this thing? Like, you want to find an n such that a to the power n plus n is congruent to 0 mod p. Can you find such an n? Try to find an n. Okay, any ideas on what n can we pick?
Zero almost works, but then it becomes one.
Yeah, so wait, n should be a positive integer.
Oh,
Okay, but let's say n equals to p. Then it equals to q of the diagonal. Yeah, fine.
so it becomes A here.
Yeah. But a might not be equals to 0 mod p, right? So, okay, one thing to notice is the n is an exponent and the other time it occurs, it's in like base. So the difference is like when n is an exponent, this thing varies modulo p minus 1. Like basically you will see a square, a cube, so on. And then you'll have a to the power n, which is equals to a modulo p, of course. This thing has cycle length, a factor of p minus 1. But this thing varies modulo p. So these two vary distinctly, right? So you'd want to use them in a nice way. So basically what I'm trying to say is you can pose two conditions on n. One condition to control this term and another condition to control this term. Whatever condition you pose here, it will be somehow related to modulo p minus 1 and this condition will be related to modulo p. And since p minus 1 and p are co-prime, you can ensure that both the two conditions hold together by CRT. Okay, so I'll just give it away.
What if we just pick it to be something mod p minus 1 and anyway we can choose it mod p?
Yeah, that is what I was trying to say, but like
for example, if we just pick it to be 0 mod p minus 1 and minus 1 mod p.
0 mod p minus 1 and
Minus 1 mod p.
minus 1 mod p. Then this thing becomes like a minus 1, right?
A to the 0 is 1, no?
Oh, what am I doing? Fine, sorry. I thought 1 mod p minus 1. Yeah. So, okay. Oh, this is actually different than what I had in mind. Fine. So, yeah, you can pick n such that n is 0, 1, p minus 1. So this is now 1 by Fermat's little theorem. And then you can take n to be minus 1 mod p. Since p minus 1 and p are co-prime, you can ensure this by CRT. Okay, what I had in mind was like 1 mod p minus 1 and then minus a mod p. It's almost the same thing though.
You could just pick it to be like r mod p minus 1 and minus a to the r mod.
Yeah, you can do anything. Fine. So yeah, you pick an n such that n is 0 mod p minus 1 and minus 1 mod p. And then a p will divide a to the power n plus n. But now p should also divide b to the power n plus n. Oh, in this, okay, yeah. So, since n is 0 mod p minus 1, you'll again get this is 0. But you do not get much information from this, right? Yeah, like this will just imply that p divides b to the power n plus n, which is good. But you somehow want to use the a to the power n thing divides b to the power n plus n. I mean, like, you want this condition eventually, right? So how do you bring that thing? Can I do this for you? Okay, so like as I also said, if we take n to be any r mod p minus 1, so a to the power n will be congruent to a to the power r mod p. And then we can pick n to be minus a to the power r mod p. So now we try this thing with this these two conditions, p divides b to the power n plus n. B to the power n plus n will be congruent to b to the power r minus a to the power r mod p. Now, which value of r makes the most sense? Like r equals to 0 will just give this is 0, which is not helpful. So like we can take any r, right? So we just take r equals to 1 and you get that v is congruent to a mod p, which is what we wanted. And now you can take p to be as large as you want, like there was no condition on p. So is this clear? Nice. Okay, we'll do one last problem. We haven't done any FE, so this is the FE we'll do. Okay, before we do that, do you know the Dirichlet theorem? Okay, nice. Uh, in an AP which is like of the form A plus ND, if A comma D are co-prime, then this AP has infinite primes in this. Yeah, nice. Okay, so you basically have that. Find all f from naturals to naturals such that A plus FB divides A square plus B times FA for all AB natural with A plus B greater than 10 to the power 100. Like A plus B is basically large. You want. It's like try this problem for 5 minutes. Okay, does anyone have any idea? Okay, firstly, what solutions work? Like try to guess the solution if that helps.
n, f of n is equal to n.
Oh, 1. That doesn't work, no?
N, f of n is n.
Oh,
Identity.
f of n is n. Yes, that works. So a square plus b divides a square plus b times fa with
B times a.
sorry. I mean, sure. Oh, yeah, f of n equals to n works, but there are more solutions which work related to this, if that helps.
Cn.
Yes, f of n equals to cn works. You can check that. So, c is basically f of 1, by the way. Most of the time it's just guessable that it should be f of 1. But anyway, that is not helpful. Yeah, so
we
now
can prove f of n is at most Cn. If C is f of 1.
you do not need any weird bonding. It's just basic divisibility ideas.
Ah.
Okay, I'll just tell this. You do the most obvious substitution, which is these two things. And you get try to use one or both of these conditions to find f for some value of p.
P minus 1 by C in the first one. Where C is f of 1.
Yeah. So what we want to do is, when you have okay, in the FE divisibility things, the main idea is like not main, but it's a good idea to make the right hand side prime. Or if you cannot make it prime, then try to make it prime power. So that the left hand side, if it divides a prime, like you have that some function here divides prime. This means that this can either be p or 1. So this gives you a lot of information. So here, what we do is we try to make this as prime. Okay, but can this be a prime? Like, is it necessary that this should be a prime for some b? If so, why?
But Dirichlet, like 1 and f of 1
Yes.
are co-prime.
1 and f of 1 are co-prime. So by Dirichlet, there should be some prime. So you take b as p minus 1 by f of 1. And then you get 1 plus f of p minus 1 by f of 1 equals to p. Oh, sorry, divides p. Clearly, this can be either 1 or p. It can't be 1 because then this thing will be 0, which means that f of p minus 1 by f of 1 is p minus 1 for large p. Also, notice that we had this condition. A plus b greater than 10 to the power 100. Like you can just take b very large. Like there are infinite primes, so take it a large prime greater than 10 to the power 100. It's just like redundant now. Okay, so you have that. You have this thing. What do you do now?
Now, the second thing that we had. Oh, no. They go into the original and put.
Yeah. So we take b
B
as
divided
p
by C.
minus 1 by f of 1 in this thing. So you will get that a plus p minus 1 divides a square plus p minus 1 by f of a times f of a.
F of 1. P minus 1 by f of 1.
Yes.
Just write it C.
Okay, bro. I'll let us see. Happy.
Yes. Easier for you as well.
Uh-huh.
Now just subtract it.
Do I have to subtract it? Fine.
Like just multiply the LS like a plus b minus 1 times a and subtract it from the right part.
Like times A, right? You're saying.
Yeah.
So A plus B minus 1 divides P minus 1 by C times f of A minus AP plus B. And you can take P minus 1 to be common. So you'll have f of A minus C minus AP minus A. So now what?
Force p minus 1 to be co-prime to it.
Force P minus 1. Okay, sure. Do you even need to do that?
Might. I mean, like some GCD might divide p minus 1, right? Actually, you don't.
Yeah.
Second.
I don't think you need to. Yeah, you don't need to. Okay, you actually need to. Fine. So, yeah, like just ensure that P minus 1 and A are co-prime. Like,
You
given
don't.
in. We do,
The
no?
maximum GCD has to be A. So you would at least have that p minus 1 by A divides C inner part.
Oh, fine.
But still, like just ensure it, just to be safe. Just
Yeah.
to be too mod A.
Sure. P to be mod and like you had an infinite sequence of primes which work. So you can take P as large as you want, and this thing will be larger than this thing. Wait, did I just say nonsense? Oh, sorry. You ensure P minus 1 and A are co-prime. Then since this thing and this thing are co-prime, you'll have this divides f of A by C minus A. And this is a constant for fixed A. So you take P to be very large, which means that f of A should be C. Like this should be 0. That is the only way it works. So is this clear? As Orphus, if you're still there. Is it clear? Okay, I assume it yes. I mean, like if you have doubt on any part, you can ask. But yeah, it's fine. Anyway, that was it for the class. We saw a couple of ideas and we saw problems. I think almost all the problems were on different ideas, like something new was there. So I hope this was useful. Bye bye.